All right, so in this lesson, we're going to talk about tangents. And tangents are really important because they have a lot of problems that come with them. So first off, a tangent is a line in the same plane as a circle that intersects in exactly one point. Okay, it touches the circle in only one point. This is called the point of tangency. Okay, now if you have more than one circle, or if your tangent line touches more than one circle, this is called a common tangent. And it is tangent to two or more circles on the same plane. So you can have a whole list of circles if you want, but there at least needs to be two circles in the same plane. Now, these are some options, but another option that you may see in your homework is when you have a line of tangency going like this. Okay? Where it touches the outsides. Now, another thing about tangent lines is that they are perpendicular to the radius. Okay? The shortest distance from the tangent to the center of the circle is the radius. And if you have a radius that connects with the point of tangency, then it is perpendicular to the tangent line. And vice versa. The tangent line is perpendicular to the radius. Now, the way you prove whether or not a line is tangent is by using Pythagorean theorem. Because if it is a tangent line, then the angle should be a right angle, which means the sides should match up. If it's not a right angle, then Pythagorean theorem won't work. So the video is going to pause, and you're going to decide whether or not GH is tangent to circle F. Go. Now, if you said no, you would be correct. GH is not a tangent line because these are not perpendicular. And the way you would set up your problem is you've got 8 squared plus 6 squared. And then I bet a lot of you said 12 squared, but 12 is only talking about this piece right here. This piece is the radius, and it's 6. So this whole side will be 18. Okay? Make sure you pay attention because sometimes the radius will sneak its way in like that. Always double check. If the number is going to indicate an entire side, it'll be centralized within the side, not off to the side like 12 is. Okay? So instead of it being 12 squared, we have 18 squared. Now it does get you the same answer in a way because 100 is definitely not equal to 324. And so therefore GH is not a tangent. But you still want to be careful and make sure you're using the proper sides, and that way you definitely get the right answer. All right, here are 2 more examples, and here is also an instance of what they'll do if they want to indicate the full side. Okay, and what you are going to do is you are going to find the value of x. You may assume, as the directions say, that the lines that appear to be tangent are tangent. And what this means is that this will be your right angle and this will be your right angle. Okay, the video is going to pause and then the answer for 3A will pop up and then it will pause again and show you the answer for 3B. Good luck. All right, and here is the answer for 3A. So simple Pythagorean theorem, solve all the way down. Make sure you simplify your radicals, even though in this case you can't. All right, the video is going to pause, and good luck. And there's the answer for 3B. Now, if you got confused in this one, it's probably because you forgot that you add these 2 pieces together. Okay, if you put 2x down, remember, if x, as it is 3, okay, x is 3, therefore the whole side length is 5. Okay, not 6. You don't multiply these 2 pieces together, you add them. And then whenever you have a binomial and you square the binomial, you're going to have to FOIL. Now in this case, we got lucky and the x squares canceled out, but remember, factoring is a valid way to solve a problem, so be on the lookout for problems where you have to factor. Okay, another fact about tangent lines is that if you have two tangent lines that share the same endpoint outside of the circle, then they are congruent. Okay, so if you've got two segments from the same exterior point are tangent to a circle, then they are congruent. It's the exact same thing, just said two different ways. Basically, it's saying that AB and CB are congruent. And if you wanted to, you can actually prove this. I know that's your favorite word, but you can prove this by using congruent triangles. Okay, because the radius is perpendicular to the line of tangency. Oops, it's a bad tangent line. The radius is perpendicular to the point of tangency. And you can always draw a shared side down the middle. And you've got two right triangles. So you could prove this theorem like you can prove all theorems, or you can just remember that when you have two tangent lines that share an exterior endpoint, those two lines are congruent. So with these problems, what you're going to do, assuming that the segments that appear to be tangent are tangent, is you can immediately set them up, since they share the same endpoint, as equal. So I have 3x plus 8 is equal to 26. And as I solve, I get 3x is equal to 18, and x is equal to 6. Okay, video's going to pause. You guys do 4b. And there's the answer for 4b. If you made a mistake, check for math errors. Otherwise, just remember that when you have two tangents that share the same exterior endpoint, they are congruent. All right, last topic. We got circumscribed polygons. Now, a circumscribed polygon is when every side of the polygon is tangent to the circle. And the reason why that's important is because if the sides are tangent to the circle, then we can apply the rule from the last slide. Okay, in which case, two tangent lines that share a same exterior endpoint are going to be congruent. But you have to make sure that every side is tangent to the circle. With these options, you can see that sometimes the sides don't touch at all, sometimes they're tangent to a few, and sometimes the sides go straight through the circle. Okay, so it has to match the criteria that every side is tangent to the circle. And here's our problem. So when we read our question, we have that the perimeter is 18 units long. Okay, the sum of all the sides is 18 units. So as I zoom in on my picture over here, I start over here at AT, and this is X. It's a tangent line. It shares an endpoint with TB, so that means that's going to be congruent. So that's also X. Same thing on the other side. UC is X, therefore BU must be X. And I'm literally just going to go around the figure like this. Okay, now notice I used a different congruency marking for each side, or for each set of tangent lines. The rule states that if two tangent lines share the same exterior endpoint, they are congruent. However, it doesn't mean that the sides of the polygon are necessarily congruent to each other. Just kind of keep that in mind. In this case, it worked out that a lot of the pieces were congruent to each other, but this is just a coincidence, not a rule. Okay, so that means this side is 2x. This side is 3 plus x. Okay, make sure you make that distinction. This is 6. And then this is 3 plus x again. So I'm going to zoom out, go back to my main picture. The perimeter is 18 units. So I can set up the equation that 18 is equal to 2x plus 3 plus x plus 6 plus 3 plus x. Okay, go ahead and solve. And when the video plays again, you'll see what x is. Keep in mind that fractions are still valid answers. Be nice to them, and remember, All right, that is the end of the lesson. I'll see you guys next time. If you have any questions, please make sure you write them down. Have a good one.